Hello and welcome to the SuperNEC Basics Help video. Today we're going to be learning how to add an assembly to our project. Please note the little text boxes in red. You can also follow along with those. For now, we'll just be following the advice and clicking on the add icon, going down to assemblies, antennas, and we're working with the SN helix. Please note at the very top of our dialog box there are 4 fields: location, orientation, segment length, and frequency scaling. So please note the location is X, Y, and Z coordinates. The location vector is basically going to be setting a default position for your assembly. Please note that the default location of each individual assembly might differ from the ones you've seen before. The orientation vector is going to be showing you how your assembly is going to be rotating relative to the X, Y, and Z axis. This might not correspond with the location you've set, so normal Cartesian rules of transformation apply. If you're going to rotate, rotate from the default position and then translate to a new position. There it is. We'll be moving on to segment length. So segment length is going to be what portion each segment of wire is of your default wavelength, which you can set in the model frequency. So we're working in 300 megahertz, 1 meter wavelength, 10 centimeter segments. The frequency scaling is pretty self-explanatory. That's every frequency you're going to be working with. What's it scaled to? Right now we have a 1-to-1 frequency scaling, meaning each frequency is just itself. But each frequency that you model at will be multiplied by that scaling. As the text box is now telling you that between your OK and cancel keys, you can see a very short explanation of what each field does. The segment length and wavelengths, and if we go to another field, you'll see that this is the spacing between turns, the length of the antenna, and so on and so forth. And this is sort of just a handy-dandy way of giving a brief description of what you're supposed to be putting in that specific field. To complete the addition of the assembly to your project, we can now just simply press the OK key now that we're happy with the specifications of our helix. And there you have it, a basic helical antenna per the specifications. And as you'll see in the text box right now, you can actually edit the MATLAB code for each individual assembly. Please follow our YouTube channel if you want some finer detail on how to achieve that.